Welcome to the Susan Brender Show. It's all about you, featuring shows on health and wellness, the performing arts, politics, and people who inspire you to be your very best. And now, here's Susan Brender.
I'm Susan Brender, and this is the Susan Brender Show. Today I'm honored to have a guest on my show. His name is Ross Knepper. He's an assistant professor at the Department of Computer Science at Cornell University. That tells you a lot. When you're a professor at Columbia or Cornell or Harvard or Yale, it's really something. Now, his research focuses on the theory, algorithms, mechanisms for automated assembly. Previously, Ross was a research scientist in the Distributed Robotics Lab at MIT. I want to welcome to my show Ross Knepper.
Thank you, Susan. It's a pleasure to be here.
You know, Ross, right now what is really trending is programs that are all about automated assembly. Why are you interested in that? And tell me a little bit about your research.
Sure. So broadly, I'm interested in how to make robots work better for and with people. And those two branches, for and with, basically describe the two aspects of my research. And a lot of it is grounded in this idea of automated assembly, which is something that robots have been doing in factories for decades. But it's something that I see as broadening out beyond just factories. For example, I have a system I call IKEABot that is capable of assembling certain IKEA furniture that you might have in your home, for example. This is a very different problem than factory assembly, because if it's in your home, it's messy, there's furniture, maybe there's a pet in the way, and so the robot needs to have a lot more situational awareness and a lot more knowledge in order to interact safely and effectively in your home.
Ross, this is a question that I feel is very important to ask you, because a lot of people are complaining that robots are putting them out of work. Now, I know that robots can be very efficient and they can do the job really well, but what about the people?
Right. So this is a great question. I think it's absolutely central to the future of robotics and the future of technology. The kind of robotics that I do is very, very complex systems, dealing with a lot of different parts, dealing with complexity of how these parts get assembled. And the fact is that these robots are not perfect. This is a very different model than what we have in factories today, where you program the robot once and then you put it alone behind a fence and just turn it on and let it go. And these robots in factories run 24/7 nonstop. This is the term that's used for this sometimes is a lights out factory. There's no reason to even have the lights on. There's no people there. This is very different, though, than robots that operate among people, because when there are people around, people actually complicate the robot's job. We think about that fence in the factory as being there to protect people. We actually have the ability to vary the compliance in our arms through antagonistic muscle actuation. So we can stiffen up our arm, like if you're preparing to catch a ball or swing a baseball bat. And you can also let your arm be softer and more flexible.
Wow.
An example would be if you're trying to catch a baseball. You need to be able to absorb the force of that ball over time, and so you want to gradually decelerate the ball. And
go ahead, please.
Yeah, and so we naturally are capable of varying the stiffness in our arms. And robots today in factories don't have that ability. It's just not built into them. In contrast, there's a new breed of robots. One of the prominent examples is called Baxter, from a company called Rethink Robotics. And Baxter has springs built into his arms, which makes him naturally compliant. And so that means that he's safe around people. So, if he swings his arm and your face is in the way, it's going to hurt, absolutely, but it's not going to kill you. It's not going to do any serious damage. And so that means now it's safe to put these robots among people, and that really unlocks a huge number of potential interactions, because now you can have, instead of the set and forget model of programming, you can have humans around the robots, and you can have humans interacting with the robots and possibly reprogramming them, helping them out when things go wrong. So just this hardware modification of adding compliance really adds a whole new dimension to robotics.
Yeah, that's very, very interesting. I'm sure that our audience would understand a little bit more when you explain to them how, now I want to take it to a different area of concern. My concern is that when there are so many robots doing all kinds of jobs, as I said before, people maybe lose their jobs, but you suggested that it's a little bit different because still people are needed to do various things. Now, if a robot is very sophisticated, it's like a sci-fi story, isn't it? It's kind of like, people are just looking into making robots that'll replace people, that'll do very difficult jobs. Now, I know that is kind of, what do I say to you, Ross? I think it's important, but I want to know how it's going to evolve. Is it going to be that we're going to have robots doing absolutely everything?
No, I don't foresee that, certainly not in my lifetime or the lifetime of any of your listeners. And the reason is there's certain things that are fundamentally just much harder for robots than for people. And sometimes it's hard to appreciate because we have a sense of what's easy and what's hard for us. So, for example, playing chess feels hard, or playing the game of Go. And so when computers were able to play chess and Go, it felt like these machines are taking over and they're doing everything that humans know how to do. And we have this notion that this is sort of the pinnacle of difficulty because these are what's the pinnacle of difficulty for us. Mm-hmm. But when you look at a robot, actually there are other tasks that we take for granted that are much harder for a robot to perform, such as dexterous manipulation of an object or recognition of an object, interaction with things in clutter. These are things that we take for granted because we've been doing them all of our lives, and in fact we evolved to do these things. And whereas this capability to do logical reasoning that's required for game playing is evolutionarily, it's a much more recent trait. And so it's less evolved, and so it feels hard. It takes a cognitive effort because that apparatus in our brain is just not as well refined. Whereas there's a huge part of your brain that's responsible for listening and using your hands. And this is just a well-oiled machine over millions of years that's able to dexterously, pick up a coin or toss a dart.
Yeah. And
we can certainly program a robot to do these things, but we're not to the point where robots can figure out for themselves how to do even simple manipulation tasks on their own.
So I think that they can do a lot of physical things, but what about having when you fix a robot or you design a robot, is there any way that we're going to see a robot have any kind of emotional representation? Will they think? Will their minds work? Will they feel different things like we feel? For example, will they have a heart, in a way, and emotions that are like we see in people?
This is a great question. This is a theme that's recurring in science fiction, in movies and books for decades. And there's a philosophical component that I'm not really well equipped to address, but technologically, robots don't think like we think. They think much more algorithmically. They think in terms of data, recognizing patterns and repeating patterns that they've seen. And you might say, well, emotions are a pattern. When a certain thing happens to you, you react by feeling a certain way. Uh-huh. if that's your definition of an emotion, then yeah, maybe robots can exhibit emotional behaviors. But as a technologist, I want to draw a line and say that no, robots are not truly emotional. They can react emotionally, but they don't feel pain, they don't feel fear, they don't feel joy the way that we do. And that's really, the unique thing that makes us human and sets us apart.
Right. Okay, so I would like you to tell our audience a story that you have about your experience with robots. There must be something that you can say that is maybe even funny. People like to really understand a little bit more about your experience with all these robots and with people and your students. Give us a little kind of touch of what, or a sample of what we would experience if we were in your class.
Sure. I'll start by telling you a story about a study that I did with robots. This was, I guess, about 3 years ago while I was still at MIT. And we were working on a paper called Asking for Help Using Inverse Semantics. And the idea was that the robot is assembling IKEA furniture all by itself, but when something goes wrong, it should be able to turn to a human, even a human who has no situational awareness, and ask for help using English, using words. And then if things go well, then the human should be able to understand the robot and respond and do the right thing. So we'd worked for several years on this technology, and of course we were very enthusiastic about it and excited to see it working in, not quite the real world, but in a real setting almost. And so we recruited several dozen subjects, and these are very, very time-consuming user studies to perform. Of course, you have to line up all the subjects and get them in the room back to back, and then for each one, you have to train them. How do you interact with the robot, and what are you supposed to be doing, and where do you stand, and all this stuff. And meanwhile, without them understanding the real purpose of the study was to examine how they would interact with the robots. So we told them, you're going to be assembling IKEA furniture together with the robots. And by the way, they might ask you for something from time to time. Go ahead and do what they ask, but don't just watch over them. You should go do your own thing, do your own job. And these kind of user studies, anytime you try to have a real system, a whole robot that's working, things are going to go wrong, and it's going to be things you don't expect. So sometimes the robot would go haywire in the middle of the study, and the person, of course, didn't know what to expect, so they might think it's normal. And of course, it's important to be scientific and rigorous. We actually put the user behind a screen so they could only hear the robot and not see it most of the time, but then when it asked for help, they would come around the screen. So there was one episode where the robot got stuck in this infinite loop. It was trying to navigate over to where a table leg was located. And for some reason, it was trying to go around the backside, and there wasn't enough room, and it would get there and back up and get there and back up. And it was stuck in this infinite loop. And I watched that, and I thought, I know exactly what's going on because I wrote this code. Actually, this was my PhD thesis code. So I'd spent years of my life on this code. I knew it inside and out. I knew what was good and also what was bad. And of course, there are flaws, right? So I saw it doing this really bizarre behavior, and I thought, I know what to do. And I actually jumped in, and there's video in the middle of the study. The user is completely blissfully unaware. I jump into the middle of the scene, and I just give this robot a big shove. And the robot goes back. Actually, it wants to keep oscillating, so it oscillates some more, and I give it an even bigger shove, and that gets it unstuck. And now it's happy, and it goes about its way. And I don't believe that user ever knew anything out of the ordinary occurred. But what I took away from this is that here we have a study about robots asking for help using English.
Wow.
And this robot was asking me for help in a different way. It was completely implicit just through its action. And somehow I was the only one on the entire planet Earth who could have interpreted the language that this robot was using to ask for help.
Wow.
And luckily I was there and could help it out. But it really demonstrates the huge gap that we have to fill in enabling robots to interact not only with their designer, but with casual humans.
Yeah.
You take me out of the scene and suddenly that robot's just not going to work.
Interesting. Very, very interesting. Now, we have all this research that's going on with people like you in different universities around the country. Is this also happening around the world?
Absolutely.
Where are we in terms of the progress that we've made? Are we behind? Are we are we more successful than, say, Europe or Asia? Nowadays it seems that China is really doing a lot of these things. So I want to know where we are in the scheme of things.
Absolutely. So I would say the U.S. is one of the key players in robotics research in terms of innovation. China's strength, they have the most deployed robots of any nation on Earth, mostly in factories. And they're growing rapidly, and this is really interesting economically because, of course, it's displacing human labor. But with current technology, there's only a certain number of jobs that are automatable. And the question is, what happens after all those jobs have been automated? That point has been reached in the United States. And so we're seeing new developments like the Baxter robot, which is designed to go into small factories where the jobs change rapidly, and it wouldn't make sense to spend a week programming a more traditional factory robot to do a job that takes 10 minutes.
Right.
So the Baxter robot can be programmed very rapidly by ordinary humans. It doesn't take enormous amount of special training. I think this is really the model of the future, is robots that maybe can even speak in English, like the example I told you about, and ask for help and interact with people and say, I think you want me to do this, is this right?
So there's a language, is what you're saying. You're developing through your algorithms. And by the way, give our audience the definition of an algorithm, because not everybody is that sophisticated and understands a word like that. Okay.
So an algorithm is, it's commonly referred to as a program or a piece of computer code. It's a sequence of logical instructions that tell the computer or the robot what to do, in what order, what conditions to check for. It has to be very thorough and complete, and you can't leave anything out. And if you leave something out, the computer just won't know what to do. It might crash, it might do the wrong thing. And this is really still where we are with robots right now, which is why programming them is so tedious and time-consuming. So a lot of my research is about how do we re-envision programming of robots? How do you talk to a robot given that in speech you can't possibly cover all of those intricate little cases? What if this happens and then this happens? What should I do?
Right.
We can program each other, if you will, just by explaining. So, let's say I hire somebody new in my lab and I'm teaching them to do a task. I teach them in English. I don't teach them in computer code. And in doing so, I'm leaving out a lot of the key details. And implicitly what I'm doing is trusting them to ask the right questions, and also I'm trusting that they have a lot of common knowledge in common with me. And we often refer to this as common sense, although a lot of it is maybe not obvious unless you've lived a lifetime and you've learned all of these things. There's lots of little interesting factoids, like you can't push a rope. Nobody ever told you can't push a rope. You just pick it up from experience. And if you're working with the rope, you wouldn't even consider doing that.
Right.
But that's the kind of thing that we omit when we're training a human. But right now you have to include in a robot program. So my research is trying to figure out how can you train robots more like the way that you train people. Interesting.
Now, robots, when it comes to medicine, and health, where do robots fit in? Do they do work that doctors need and can use for anything, or nurses or people in the health field?
Yeah, this is a really fascinating case. I think, of course, there's a lot of new technology in medicine because there's a lot of money available to commercialize things. And there's a really interesting robot called the Da Vinci, which is a microsurgery robot. So the surgeon looks through a screen. He has his head basically inside the machine, and he has these joysticks that he uses to control two sort of micro tweezers that are inside of the patient. Mm-hmm. And he sees this zoomed in view, which is much magnified, and so he can really do very detailed work and understand what's going on.
Wow.
And it's really interesting. Of course, the human is still completely in control, mm-hmm. because he's calling all the shots. But on the other hand, he has his head inside of the machine. And what implications does that have on the functionality of a team?
Yeah.
A colleague of mine at Cornell, Malte Jung, is studying this very question, actually looking at the social dynamics of the team in the operating room, mm-hmm. and how does it affect things if the master surgeon has his head inside of a machine. He can't see social cues, he can't talk as easily with the nurses, et cetera. So mm-hmm. We're still figuring out what's the right way to integrate robots into our daily lives, into our jobs. What are the right use cases? We need experts not just in robotics, but in human-computer interaction and graphics and all kinds of different disciplines.
Mm-hmm. Now, Ross, if you had a chance to really think about what would be the most interesting thing for you to do with regard to your career and with regard to the whole notion of robots doing various things, what would be the best part of this research that you think would be great for you?
Sure. And this actually comes right back to that question about jobs that you asked me earlier. So my research vision, is to build a robot that humans will treat as a peer rather than as a tool or a machine. And that means you can turn to the robot and ask questions. It can help you out. It might also turn to you and ask you for help. But there's a lot of other things that go into being a peer. You engage in small talk. You ask about each other. You know a lot about the other person and their history and their life and so on. And I'd like a robot that's able to actually socially engage with people at the same time that it's physically engaging in terms of the work. And this is not at all a human replacement. I actually see this as a human augmentation. Mm. So these robots can never replace people because people have capabilities we just don't know how to achieve in robots. And I want to emphasize that message because I know there's a lot of fear about this question.
Right.
And if you think about what humans do well and what robots do well, it's really complementary. So humans excel at variety, at challenging tasks, at doing something different from day to day, problem solving, troubleshooting. Mm-hmm. That's what makes life exciting. For robots, they crave routine. They just want to do the same thing very precisely over and over again, day in and day out. They don't like variety. They don't like errors because they don't know how to handle any kind of failure right now. And so my vision is, why can't we have a human and a robot working side by side and actually sort of get each other on some level so that they trust each other and they're comfortable working together? Mm-hmm. And what I see is this is actually the path forward in the U.S. towards more manufacturing, towards sort of bringing those jobs back. I think a lot of people right now are worried about how can we bring jobs back that have gone to China, et cetera.
Right.
Those jobs, as they were, are not coming back economically. There's just no way to bring them back. But what we can do is use our strength in technology to create new jobs mm-hmm. that are more stimulating for American workers and higher productivity that can increase our output, increase our competitiveness in the world economically. If we can build cheaper products, not because we're paying our workers less, but because we have robots helping us, then we can actually compete with people that are earning $3 an hour in China.
That's great. Now, in the aftermath of the most compelling presidential election in the U.S. history, I think, do you think that the new administration under Trump is going to make a difference in the monies that are available for research, for all the work that you're doing right now on the robotics field? Will it change anything as far as you're concerned?
Absolutely. This is a question that gets asked every time a new administration comes in. It has its own priorities. It turns out the Obama administration was really good for robotics research in particular. For whatever reason, Obama just loves robots. Under his administration, they started some new programs, including the National Robotics Initiative, which has been tremendous for robotics research. It's funded a lot of very important projects. And I'm sure that the new administration will have its own priorities. Mm-hmm. One of them is border enforcement, which is an area that we see robots increasingly playing a role in. We can have autonomous systems patrolling the border on land, in the sky, et cetera. So I do anticipate there will be shifts in funding just based on political priorities.
Right.
I don't know what they're going to be. I mean, that's for the politicians to decide. But I hope that I actually want to send a little bit broader message. Robotics research is very important, mm-hmm. but there's a lot of other kinds of important scientific endeavors as well. And what I don't want to see is robotics research benefiting at the cost of sacrificing research on the environment or research into health, or there's so many other important areas. Basic research in the humanities even. There's right. tremendous investments in the humanities, which are equally important with science and technology. And I think it's important for all of us to recognize that what makes America great is all of us. It's all of the pieces that we bring into America. It's not just our science. It's not our politics. It's everything. It's the arts and the sciences all together.
Now, last but not least, what I'd like to find out is if you had a chance to say something to our audience that you really believe is very important to leave this show, what would you want to tell them?
Study hard in school. I think that's the one biggest investment. I mean, if you're past that age, then find somebody who you can mentor in school and help them out on their homework and show them why science and technology are so exciting. I think there's a huge hole right now, and we just cannot create enough new computer scientists to fill that hole in terms of employment. There's hundreds of thousands of empty jobs that are going unfilled, and this is despite the fact that our computer science program here at Cornell and all around the country is just exploding in terms of enrollments.
Wow.
So it's a wonderful time to be in computer science, to be in engineering, to be in math. If you are worried about finding a good job, it all starts with studying hard in school. Study your math, study your science. Mm-hmm. It's all based on that.
Well, my guest today has been Ross Knepper. He's an assistant professor in the Department of Computer Science at Cornell University. He's working with robots, and he has a lot to say. Now, Ross, do you have a book, or do you have anything that you would like to tell our audience about?
Yeah, so I don't have a book yet, but a fun thing, if you want to go on YouTube, you can search for IKEA Bot, and you can actually see videos of my IKEA Bot system building furniture all by itself.
Oh, that's great. Okay, well, thank you so very much, Ross Knepper, for being on the Susan Brender Show. You've taught our audience a lot and gave them a lot to think about. So I want to say thank you again.
Thank you. It was a real pleasure.
Thank you for listening to the Susan Brender Show. To be a guest, email sebrender@yahoo.com.